Hi everybody. Now I'm just back with switching, CCNP switching. Here we'll see the difference between Inter-VLAN routing, which is based on a router on a stick, and on a layer 3 switching, which is on a SVI interface. So we'll just see the difference between exactly how devices works when you have a layer 3 router and a layer 3 switch. So now here on the slide you can see Inter-VLAN routing use an external router. So now on a LAN network in switching we can see that we can create multiple virtual LAN networks. So say I have a company which has say 10 or 20 users, 10 or 20 different networks, or 10 or 20 different departments. Each of them I can give a separate LAN network. So these separate LAN networks can communicate within themselves independently because they are on the same switch or on the same VLAN. But if a switch or a VLAN 10 PC, if it has to communicate with VLAN 20, they normally require a layer 3 device called as a router. So normally this you would have seen as a router on a stick environment, where you can see here, it provides a single link or a trunk link between a switch to a router. So the main switch over here which is communicating to the router will be on a trunk mode over there. Those are the operating modes of a trunk. Now the router, can you see that you have only a single cable from a router which is connected towards a switch. So normally on a single router's physical interface you will be only able to give a single IP address. Now say I have a LAN which is VLAN 10 and VLAN 20. So this 10 VLAN and 20 VLAN normally requires a default gateway. So both those on a single interface I will not be able to do put two IP addresses. So on a router's interface I can create something called as sub interfaces. You have a concept called as sub interfaces. On a sub interfaces you can put n number of IP address on a single interface, so that you can allow different VLANs to communicate within each other. So on the diagram you can see that it is an encapsulation.1 queue, which is an 802.1 queue trunk which has VLAN 10 and VLAN 20, which will be acting through the same interface. So through the same physical interface you will be creating multiple logical interfaces, so that VLAN 10 and VLAN 20 can simultaneously access through that. So on a physical interface, say for example if the interface is FS0/0 on the router, you will never give an IP address on 0/0, but on a physical interface you can see FS0/0.10 and .20. So those are called as sub interfaces. Those numbers represent them as sub interfaces. On the sub interfaces you will be able to give two different physical IP addresses. Those IP addresses can be given on the PCs or on the server as a default gateway. So now this environment or this particular structure, you call it as a router on a stick. So can you see here they say traffic from PC 1 enters a switch on VLAN 10. So now if a PC on VLAN 10 has to communicate with the server on VLAN 20, the router, the data from the PC will go through VLAN 10. It will go through the trunk which enters FS0/0.10, and the router will have a routing table which will define the network for VLAN 10 as well as for VLAN 20. Now and what will happen is it will go through interface FS0/0.10 and the data comes back through FS0/0.20 and reaches the end. So this is the structure which you have on a router on a stick environment. What are the advantages and what are the disadvantages of we having a external router? Say on a LAN network, if you have a router which is used to do routing between multiple VLANs inside the same LAN network, here they say some of the advantages and disadvantages. So you can read out very first thing. Advantages is works with any switch since layer 3 servers are not required on a switch. So now when you have only a layer 2 device, that is a switch which only is capable of doing L2 operations, you don't need the switch to do the L3. A router can work with L2 router which can do a L3 operation, and the implementation part is much more simpler. You can see the configuration. Then the router is exactly a device which communicates between two different LAN networks. So exactly those are the advantages, but you can see on the other side there are some disadvantages on this. Say for example the router had overloaded with so much of data, and imagine the router fails you have a single point of failure. So what will happen is, now routing between two different VLANs will not be possible, only the routing between the same VLANs will be possible. So those is a problem, and latency is another problem. Why? Because you have a single interface which is 100 Mbps or a 1 gig. If it has been subdivided into multiple VLANs, what will happen is all the bandwidth will be divided, so latency comes into picture, and multiple times switch chases, and router makes software, and also the thing is, router makes the routing decision based on software, whereas switch is a hardware based decision, whereas a router is a software based decision, so it is much more slower than a switch. So now when you have a router, you will have a time delay for a router from a VLAN 10 or from a PC from VLAN 10 to communicate back to VLAN 20. So that is why they are coming up with router versus switched campus environment. So in this particular layer, you can see two different diagrams. You have a L2 switch on one side and a L3 switch on the other side. So see, L3 switch is nothing but a Cisco has come up with this technology, where L3 technology, where our switch itself will be able to do routing. So you don't have to buy an additional device which is a router which exactly does routing, whereas switch itself has a capability to do the routing. So Cisco has integrated the routing configurations onto a switch so that the switch will also do the routings. Now normally if you buy a L3 switch, the L3 switch will never do routing. So on the configure terminal, you have to enter a command called as IP routing. So normally with the command IP routing, Cisco switches will do a operation called as routing. Okay, now and see, every switches has L2 ports, or the ports on the switch will be L2 capable. So now when you have a L2 device, it is not possible for you to create an IP address on it, because L2 will not support IP address. So but L3 switches has a capability to adopt or accept IP address on the interface. But normally if you go to an interface and if you say IP address on the particular interface, it will not accept the command, because switch always works as a layer 2 device. Now you have a command called as switch port, which you normally give when you configure a interface to be on access 10 or access VLAN 20. You would say switch port mode access. So what is the word meaning of switch port, or what exactly the word switch port gives a capability is? Switch port gives the interface an L2 capability. So every L2 devices or layer 2 switches by default has a has switch port enabled on this, because they do layer 2. Now on a layer 3 switch, if I don't want the interface to be part of layer 2, I can say no switch port. The command goes like this: no space switch port on the configure terminal. So what will happen? The interface will act as a routed port. So on a routed port, normally you will be able to install an IP, or you will be able to put an IP address. So what will happen is, you will be able to do routing on it. So here switches has come up with some concept called as switched virtual interface. You can see on the screen as switched virtual interface. So now I just want you to compare this switched virtual interface with the option which you have seen earlier, or called as router on a stick. See, router on a stick was the IP address you are creating on the logical interface of a router. Now this switched virtual interface is a command that you are configuring on the switch virtual interface. So there is no physical interface present on the switch. Instead you can create logical interface saying interface VLAN 1, 2 or 3 depending on the interfaces you have. So you can go to the configure terminal, you can say interface VLAN 10. So on interface VLAN 10 you can put an IP address, say 10.1.1.1, and you can say the subnet mask 255.255.255.0. So now a new virtual interface will be created on the router. If you type show IP interface brief, you will be able to see a new virtual interface is created on a switch which says interface VLAN 10 with the IP address. So now this is called as switch virtual interface. Now a switch can do multiple switch to virtual interfaces. So when multiple switch to virtual interfaces are created, see, the use of router to connect to multiple VLANs is not needed, whereas now the switch itself has a capability to do routing. So now this IP address which you have given on interface VLAN 10 can be used as a default gateway for the PCs. So now here the point says router uses interface or sub interface to interconnect multiple VLANs, the same you saw earlier. Multiple switches use SVI. So the switch to virtual interface, it's nothing but a virtual interface, but those interfaces will act as a real IP address onto the default gateway. So now I hope you got what is the difference between a router which does L3 and a switch which does L3. So you don't have to buy a device called as a router which does L3 operation, where you can buy a switch, a layer 3 switch which can do switching as well as routing. Now, so here this switch which does layer 3, you call it to be MLS or multi-layer switching, you call it to be. So what does multi-layer switching do? Multi-layer, as you see on the slide, multi-layer switch combines with the ability of a switch to forward frames. As I said you earlier, switch will forward frame from VLAN 10 to VLAN 10 itself, whereas a router will forward the packet from or the frame from VLAN 10 towards VLAN 20. So routing is possible with routers and switching is only forwarded is done with switches. Now see, when the multi-layer switch, you can see that it will switch within the same VLAN and it will do routing between multiple VLAN. So the capability of router is also included, so you can do routing between multiple VLANs as well as switching between the same VLANs. Now there are so many advantages between the multi-layer switch, what you see. So now, as I said you earlier, a switch works at hardware speed and a router works at software speed. So if you see here, you can see the frame structure and the IP header structure, all those things. Now imagine the data is coming from a VLAN 10 and the data is going to VLAN 20. So now the data will have a source MAC address, a destination MAC address, sender's IP address, receiver's IP address, you have TTL value, you have frame check sequence and all those things. Now when the data enters a router, the router has two planes. Normally you call it to be a data plane which works with interfaces, and the next plane you call it to be a control plane which will have CPU and the routing table. So now this control plane is otherwise called as route processor inside this, and on the data plane you have a switching engine. Now when the packet comes to the router will normally remove the L2 address at your data plane, push the data upwards towards the control plane. So now when the data goes up, the routing table will be checked and the router makes a decision on to which interface the data has to be forwarded. So now after making the decision, the data comes onto a data plane and it will be forwarded. Now that's why you call it to be a software suite, because the data is coming into the router from the data plane, it removes the L2 information, goes to the layer 3 where it will do the routing information, then comes down, adds the L2 information, pushes the data. So imagine the time taken for a router to process each packet like this. So that's why you call it to be software speed. Now here you can see the MAC address and all taking place. Now there are three type of technologies involved in this. The very first thing you call it to be packet switch technology. So in packet switch technology, as I said you, every packets will come into the router. The router will check onto the data plane and the data will be pushed onto the control plane, comes back. So now when each packet is going through all these stuffs, imagine the time taken to process all these stuffs. So later the technology they evolved is called as cache driven switching. So what is cache driven switching is, say once the first packet gets in, say it goes to the control plane, comes back with the routing information, and a cache entry will be created for that particular route on the data plane. So now when a cache entry is created on the interface, the second packet, if it is going through the same network or the same routing is done, he doesn't have to push the data towards the control plane in the second time, because a cache information is put onto the data plane. So now the second information will come to the data plane, nothing will be pushed onto the control plane, every information will be forwarded. So now you can just imagine how much more easier they have made it, because even though every packet goes through the data plane, control plane, then data plane and forward through the interface, now only the first packet has been pushed on the cache driven switching. Later they came up with something called as CEF, otherwise you call it to be Cisco Express Forwarding, which is done in Cisco devices or Cisco switches, or this is called as topology based switching. So now what will happen is, no entry is by default, the routing table entry is brought into the control data plane, and those information you call it to be FIB, otherwise you call it to be forward information base. See, now remember one thing, no data is going from the data plane towards the control plane. All the data, when it comes to the data plane itself, the very first packet is also not going to the control plane. By default, the entry from the control plane or the routing table information by default is brought into the data plane. So that information is otherwise called as FIB, and the L2 information will be called as adjacency table over here. So now when the packet gets into the router, only the data will go through the data plane. So this data plane checks the FIB, checks the adjacency table, pushes the table. So this is called as much more better technology, where your data will be processed much more faster. So this technology is otherwise called as CEF, Cisco Express Forwarding. So now you can imagine, from packet switching, the next technology which was evolved was called as cache driven switching, and later we have come up with a technology called as Cisco Express Forwarding or topology based. So now imagine how much more faster is the data transfer happening rather than a software based switching. So now the switching is happening based at the hardware speed, and also routing is based at their hardware speed. So now you have a much more faster mechanism of data transfer than routers in switches. So this is the functionality of L3 switching or layer 3 switching. Hope you enjoy this session. Thank you.